Here we're going to sketch the graph of the function y is equal to sine of pi x over 4. We're going to include two full periods. First, let's look at the amplitude. We know the coefficient of sine here is 1, so the amplitude must be 1. That means our graph will extend up to positive 1 and down to negative 1. Our vertical shift, since we have no d component in this equation, if you remember, our standard form is d plus a times sine of bx minus c, and there's no d, then it means there is no vertical shift. Our period is equal to 2 pi over b. Here our b is equal to pi over 4. It's the coefficient of the x. So to find our period, we take 2 pi and divided by b. So 2 pi divided by pi over 4 will give us a period of 8. So for one complete cycle, we'll take 8 units. Now since we need 2 full periods, we're going to extend our graph all the way up to 16. So from here to 8 would be 1 period, and then from 8 to 16 would be our second period. So we know for one period, right in the center would be our intercept. We also know for the sine, it starts at 0, 0. At the middle between the two intercepts would be our maximum point. We know from here to here, between the intercepts would be our minimum point. So if we sketch this section of our graph, we have it going like this, coming down. So here we have one cycle of this function here. If we continue, we have our intercept here and here again. At 10 will be our maximum. At 14 will be our minimum. So if we continue, here we have 2 full periods of our graph y is equal to sine of pi x over 4. In this example, we're going to be sketching the function y is equal to 4 cosine of x plus pi over 2 plus 4. From our general form of our equation of our cosine function, we know that 4, the coefficient of the cosine, is our amplitude. So for this function, our amplitude is 4. We know our period is equal to b over 2 pi. So our b is the coefficient of x. So it would be 2 pi over 1. So our period is 2 pi. Our vertical shift. Our vertical shift is our d. Here in this problem, they put d in the back. It's no different if it's just 4 plus 4 cosine. This is still our d, which represents our vertical shift. So this means that our entire graph is being shifted up 4 units. To find our horizontal shift, and we know there's a horizontal shift, since this is in the form of bx plus c. For our horizontal shift, we find the left endpoint. To find the left endpoint, it's x plus pi over 2 is equal to 0, which gives us x is equal to negative pi over 2. To find the right endpoint of one cycle, it's x plus theta, or in this case, x plus pi over 2 is equal to 2 pi, which gives us x is equal to 3 pi over 2. So these are our left endpoint and our right endpoint of one cycle. So now let's get graphing this. Here in black, we have our basic cosine function. Y is equal to the cosine of x, where cosine starts at 1 when x is equal to 0, and at pi over 2, cosine of pi over 2 is 0. The cosine of pi would be negative 1, cosine of 3 pi over 2 is 0, and the cosine of 2 pi is back to 1. So here this is our basic cosine function, and we have a little more than 2 cycles of this. We know that our amplitude is 4, which means it's going to increase the amplitude of our basic cosine function from 1 to 4. So here, instead of the amplitude being 1, it's now 4. So y is equal to 4 cosine of x is shown here in blue. So it's basic cosine function, however now our amplitude is 4. So instead of going up to 1, it's now up to 4. All the way back to pi over 2, down through to negative 4. So from 4 to negative 4 because our amplitude is 4. So now we have taken account for this. We now need to think of our horizontal shift and our vertical shift. So this graph in blue, which is 4 cosine of x, is shifted to the left pi over 2 units. So instead of starting here, it's going to start here because it's shifted to the left pi over 2. Instead of ending at 2 pi, which is here, it's going to end at 3 pi over 2. Not only that, it's shifted horizontal, it's shifted vertical 4 units. So it shifted pi over 2 units and then up 4 units. So shifted pi over 2, up 4. So this is our new starting point for this function. The right end point shifted pi over 2 units and up 4. So this is our next ending point. From here, we have our minimum of pi over 2. When x is equal to 0, we have our y at 4. And we can continue doing this and fill in all our points. So here, in purple, we have our function y is equal to 4 times the cosine of x plus pi over 2 plus 4, which is our basic cosine function with an amplitude of 4 in blue, shifted pi over 2 units and up 4 units.